Most weapons were built to fight. This one was built to survive capture. Hidden inside a jacket lapel, the SOE issued a knife so small many operatives questioned its usefulness. It could pass a search. It could stay hidden under restraint. But there was an obvious problem. The knife was extremely short. The reach was severely limited. And in real captivity conditions, it was useful only at very close contact. Yet British planners approved it, because in certain situations, even a miniature knife was considered better than nothing. Station 9 opened a revised requirement review. SOE field losses prompted renewed concealment urgency. Captured agents reported repeated search failures. Existing escape tools failed under controlled inspection. Pocket silhouettes exposed standard emergency blades. Metal density increased detector detection probability. Priority shifted fully towards search survivability. Combat effectiveness remained explicitly secondary, while the project retained the Lapel Dagger designation. Engineering staff revalidated dimensional constraints. Garment integration remained the governing limitation. Tailoring officers re-examined lapel cavity tolerances. Early prototypes exceeded safe concealment thickness. Dimensional reductions followed garment stress testing. Final blade length remained near 38 millimeters. Overall length stayed below 75 millimeters. Width limits were tightened during redesign review. Spine thickness averaged under 3 millimeters. Material selection again favored Sheffield carbon steel. Alternative alloys were briefly reconsidered, then rejected. Edge retention remained the decisive material factor. Heat treatment followed controlled batch protocols. Target hardness remained near 58 Rockwell. C hardness variation triggered several early rejections. Metallurgical staff tightened furnace calibration ranges. Subsequent batches showed improved uniformity. Blade geometry retained the narrow spear profile. Double-edge proposals were reviewed and dismissed. Single-edge grinding reduced manufacturing complexity. Miniature grinding fixtures required further refinement. Hand finishing remained unavoidable for tip precision. Magnified inspection became mandatory for every unit. Reject thresholds were lowered after early failures. Handle configuration underwent renewed scrutiny. Conventional grips still exceeded concealment limits. Flattened tang geometry remained the only viable option. Separate grip scales stayed permanently excluded. Cord wrapping again served as the primary solution. Earlier cotton wraps had proven unreliable. Oil contamination loosened natural fiber bindings. Wax-treated linen continued to show superior performance. Revised binding tension standards were introduced. Workers received updated wrapping instructions. Inspection teams measured wrap compression manually. While loose bindings triggered immediate batch rejection. The tang continued full length through the handle. No guard remained part of the configuration. Guard absence improved lapel integration geometry. Safety officers again noted elevated slip probability. Risk acceptance documentation was reaffirmed. The dagger remained classified emergency equipment only. Primary combat doctrine remained unauthorized. Mounting systems received additional field review. A reduced thickness leather was re-examined and rejected. Perspiration exposure degraded leather too quickly. Engineers reaffirmed treated fabric sheath construction. Multi-layer canvas maintained structural consistency. Metal reinforcement remained strictly prohibited. Detection, probability drove that restriction. Retention again depended on tight friction tolerances. Early sheath wear still produced loosening incidents. Quality control introduced insertion cycle testing. Each sheath endured repeated draw simulations. Units failing retention thresholds were discarded. Interior wax treatments were reformulated. Later production showed improved blade security. Attachment methods triggered further tailoring concerns. External mounting hardware remained unacceptable. Sew-in pocket geometry was carefully standardized. Tailors received updated installation diagrams. Garment distortion remained under strict monitoring. Most placements continued inside jacket lapels. But the operational nickname persisted unchanged. Search resistance trials expanded during late testing. Military inspectors conducted controlled pat-down procedures. Secondary inspection teams performed deep searches. Superficial searches rarely detected the dagger. Detailed inspections occasionally located concealed units. Detection events were logged numerically. Training adjustments followed each recorded failure. Garment quality proved critically influential. While loose tailoring increased exposure probability significantly. Operatives received stricter clothing preparation guidance. Rapid access under restraint became a priority concern. Engineers expanded wrist binding simulations. Multiple restraint configurations were tested. Access times varied across trained personnel. Some subjects failed complete extraction. Grip orientation proved consistently critical. Incorrect angle increased self-injury incidents. Medical staff documented minor hand lacerations. Safety memoranda recommended revised training drills. Timed extraction trials were formally introduced. Performance benchmarks were established for operatives. Several trainees failed minimum speed thresholds. Remedial instruction programs were implemented. The blade's minimal size remained limiting. Effective reach stayed operationally restricted. Penetration depended entirely on exact placement. But reports repeatedly emphasized close proximity requirements. Field doctrine continued labeling the weapon emergency only. Manufacturing oversight tightened during 1943 reviews. Sheffield workshops maintained controlled output quotas. Production volume remained intentionally limited. Serial marking practices remained inconsistent. Many units still lacked visible identification. Inventory tracking remained partially unreliable. Packaging continued under strict deniability protocols. Each dagger shipped in plain wax wrapping. Outer crates carried generic coded markings. Documentation avoided descriptive weapon terminology. Transport followed compartmentalized SOE routing. Distribution remained selective across operational theaters. High-risk insertion teams received priority allocation. Escape kits occasionally included the dagger. Training manuals were revised with updated guidance. Operatives practiced constrained extraction drills. Finger placement instructions were more explicit. Improper handling continued causing slippage incidents. Instructor reports noted uneven proficiency rates. Supplemental training cycles were ordered. Despite limitations, core requirements were met. Search survivability metrics satisfied acceptance criteria. Combat effectiveness remained deliberately compromised. Alternative miniature weapons were again reviewed. Button knives still failed reliability standards. Folding blades exceeded thickness tolerances. Spike concepts demonstrated poor retention reliability. Garrote wire remained a separate equipment category. The lapel dagger retained its narrow purpose. Manufacturing efficiency remained under continuous review. Manual grinding still limited throughput. Mechanization trials again showed inconsistent precision. Blade geometry continued requiring skilled finishing. Reject rates gradually declined after process tightening. Heat treatment stability improved measurably. Handle wrapping variability also decreased. Moisture exposure testing continued routinely. Revised linen treatments held firm under stress. Packaging labels remained deliberately vague. Crates carried only coded identifiers. Transportation followed established covert supply chains. Documentation stressed plausible deniability throughout. Operational feedback arrived intermittently from the field. Reports confirmed continued concealment success. Combat usefulness still received mixed evaluations. Limited reach remained the primary criticism. Precise targeting was consistently required. Restrained conditions reduced practical effectiveness. Engineering staff acknowledged the inherent compromise. The project never pursued primary lethality. Its function remained contingency survivability. Late war reviews again examined dimensional margins. Proposed blade extensions failed concealment standards. Command authorities rejected all enlargement proposals. Material allocation disputes briefly delayed output. Priority boards ultimately sustained production. Post-1944, manufacturing gradually declined. Operational focus shifted toward alternative equipment. Remaining inventory continued controlled distribution. Post-war recovery located numerous unused examples. Many remained sealed in original sheaths. Surviving specimens display consistent machining. Blade geometry stayed tightly standardized. While handle wraps show minor batch variation, no major redesign ever entered production. The lapel dagger remained fundamentally unchanged. Archival reviews classified the program technically successful. Success criteria remained narrowly defined internally. Search survivability stayed the primary metric. Lethality remained explicitly secondary throughout development. Modern evaluation supports the original assessment. Miniaturization imposed unavoidable functional limits. Engineering trade-offs were thoroughly documented. The design reflects extreme concealment prioritization. Every dimension served inspection survivability. Practical combat value remained deliberately constrained. The weapon addressed highly specific capture scenarios. Material choices supported compact structural integrity. Manufacturing compromises reflected wartime urgency. Quality control balanced speed against reliability. In technical terms, the requirement was satisfied.